Good morning and welcome to our discussion today. Today we want to look at once again the probability distribution of the toss of fake coins. And this morning particularly we are going to look at the probability distribution when three fake coins are tossed up together. And then our interest is on random variable x that counts the number of heads that come up when we toss these three fake coins up together. What are we going to determine in this trial? What we are going to determine are categorized under three subheadings. We are going to determine the sample space of that trial of the toss of three fake coins. We are going to determine the range space, and then we are going to determine what we call the probability distribution. So we quickly begin to look at what we call the sample space. Of course, when we talk about sample space, we are talking about a set that contains all the possibilities that one can have when one performs a certain defined experiment. And of course, we are discussing three fake coins here. Let me use this side of the board. We are talking about three fake coins. Three fake coins. Of course, when we throw three fake coins up, it is possible that we can get three heads from all of them. So we now talk about what? Where I can get three heads. It is equally possible that I will now throw it up now and I'll have two heads and a tail. Then here I have what? 2H, comma what? Comma T. It is equally possible that I throw it up now. I have just a head and two tails. So here I have what is called H, comma 2T. And it is equally possible I throw it up now and all of them will become tail. So I have a place where I have 3T. Let us see the distributions of the head and tails under these categories. So under here, I have what? Head, head, head. That is now the three heads occurring in the three coins. Under this place, I have what? Head, head, and tail. However, there are other ways of the arrangement of this head, head, and tail. So I can equally have it where the tail comes first, and I have tail, head, head. It still falls under this category. Or where the tail comes at the center, and I have head, tail, and what? Head. It equally falls under this category. There is no other combination you can have under this place. So we come over here. When we come over here, what we have here becomes what? I have head, tail, and tail. There is also another combination where the tails can come first, and I have tail, tail, and head. And there is a combination where the head can be at the center, and I have tail, head, and tail. No other combination is possible here. So the last one is where I have three tails. So here is tail, and here is tail. Okay? Now, I am now going to collect the sample space. The sample space now S will now be a set that contains head, head, and head for this one. I come over here. I have head, head, and T, comma, which is this. Then this one becomes what? T, head, head, comma. I come to this one. This is head, T, and head. I am through with this. Now I am here. Then I have what? Head, tail, and tail, comma. I come to this. Tail, tail, and head, comma. I come to this. And I have tail, head, and tail. Then lastly, I have what? Tail, tail, and tail. I will close up what the set. So this is the sample space which represents all the possibilities you can have when you toss three fake coins up together. So this is the sample space. So I want to now come and determine what is called the range space. I want to determine the range space. This random variable x here counts the number of head that occurs. So what this random variable x is going to do is to come into the sample space and continue to count the number of what heads that occur in each of these possibilities. So I have that R subscript x, which is the range space, will be given as when that random variable comes in this particular point, it is going to count 1, 2, 3. That is 3 heads. So here is 3, comma. It will come here to count. It will count 1, 2. It's only 2 heads that is here. It will write 2. When it comes here, it will equal count 2. When it comes here, it will equal count 2. Then I'm here. When it gets to here, it will count 1. Comes here, it will count 1. Comes here, it will count 1. When it comes here, there is no head here, so it will now put it as what? As 0. Okay? Now, but we define the range space as a set of the real values or the real valued function of the observations in the what? In the sample space. So because we are defining range as a set, we are not going to allow the repetition of a number inside that set. So this range space will now be written as, I have now R of x is given as, set will open. Here becomes what? 3, comma. Here I will only take 2, comma. Here I will take 1, comma. And here I will take 0, something of this kind. And this becomes what we call a range space. Now, at times, remember that the change of position of an element does not change the meaning of that set. So at times you see people write the range space to be R subscript S will be given as here is 0, comma 1, comma 2, and comma 3. You close up what the bracket this way. So this is what we call now the range space. This 0 here means where head did not occur. This 1 here means where one head occurred. This 2 here means where 2 heads occurred. And this 3 means where 3 heads occurred. So we are going to use this range space now to determine the probability distribution of the toss of 3 fair coins. Look at how to determine the probability distribution. When we come to the first one, this 0 means where no head occurred. That is 0 head, where we have 0 head. So I will now come here and say P that H is equals to 0. That head did not occur. This will be given as, we now come to our sample space and say in how many places did we have an outcome where we never had what? A head. It is only this place. And the total number of this observation inside this sample space, they are 8. 1, 2, 3, 4, 5, 6, 7, 8. So meaning that it is one place out of 8. So this thing becomes what? 1 all over 8. Comma. We now talk about where h is equals to 1. That is this place. Where we only have one h that occur. That is one head. We now come to this sample space and count the number of places where we have only one head. We have only one head here. We have only one head here. We have only one head here. So there are 3 out of 8. And then we have that this thing becomes 3 over 8. We now come where we have only 2 heads. That becomes P of H being equals to what? Equals what? 2. This will be given as, we count. We have 2 heads here, 2 heads here, and 2 heads here. 3 out of 8. So this becomes what? 3 all over what? 8, comma. Then we now talk about P that H is equals 3. That is, the number of places where the number of heads that we have in each of the trial or in the trial is 3, is only in this place, which is only 1 out of what? 8. So this becomes what? 1 all over what? 8. Then you make a table to show the probability distribution. You now have a table like this. You have a table like this. You have this. That is your random variable x. This is your p of what? X. You close it. Then you have this. Remember that your range space begins from 0 and ends in 3. So here is 0, 1, 2, 3. Probability for 0 is 1 over 8. 1 all over 8. Probability for 1 is 3 over 8. So this is 3 over 8. Probability for 2 is what? 3 all over what? 8. And probability for 3 is what? 1 all over 8. So this is what we call the sample space. This is what we call the range space. And this is what we call the probability distribution. But there is something that we want to point out clear here, which of course is going to directly link to our next class we are going to have this morning. Now, it was possible for us to list all these possibilities because we are dealing with only 3 coins. The question becomes now, or the topic changes when we are now discussing 4 coins, where the combination becomes larger, up to 16 number of outcomes. So listing the 16 possibilities now might pose a challenge. And then in an exam, we are still told that we have to determine the range space, and then we have to determine the probability distribution. And for you to determine the probability distribution, it is possible that you know the nature of your sample space. So that is what we are going to show now. Another way you can navigate your way is when the number of coins now increases or the number of trials now increases. Let us show you something. What we have here was what? 3 heads. And the number of coins that we are using is what? Is 3. So if I want to talk about a place or the number of places I'm going to have 3 heads, I am going to use something like this. The law is that I'm going to use n combination what? R. Where this my n is talking about the number of coins or talking about the number of trials. And this R is talking about the number of heads that I am interested in obtaining or that is likely to come out when I throw that. So this my R here takes a value 3 where I have 3 heads. It can take a value 2 where I have 2 heads. It can take a value what? 1 where I have what? 1 head. And it can take a value 0 where I don't have head at all. And if I do that, what I'm going to have now becomes, do permit me to clean here, do permit me to clean here. If I do that now, what I'm going to have here becomes, our interest is on n combination what? R. Okay? And my n is 3 because of 3 fake coins. And I'm looking at the 3 heads this time around. So R is equals to 3. So I will now say when R equals 3, when R equals 3, I am now going to have 3 combination 3. And of course, 3 combination 3 is what? Is 1. And that was why we only had only one place where we have 3 heads. Then it now say when R becomes now 2, when R becomes 2 now, what I will have is now 3 combination 2. And you know that 3 combination 2 is what? Is 3. And then when R becomes what? 1, you are now going to have what? 3 combination 1. And of course, you know that 3 combination 1 is going to give you equally 3. And then when R becomes what? 0, you are going to have 3 combination what? 0, which becomes what? 1. Because 3 combination 0 is what? Is 1. This thing has told you that, or has told you that the number of places where I have 3 heads is 1. Number of the places where I have two heads is 3. Number of the places where I have one head is 3. And number of places where I don't have a head is 1 when 3 fake coins are tossed up together. So if I want to determine the range space using this approach, I will now write that my R subscript X is now will be given as, here is my 0, which is 0 head. Here is my 1, which is 1 head. Here is my what? 3, which is 2 heads. Here is my what? 1, which is about 1 head. Where is my 2, which is about 2 head? And here is about 3, which is my 3 head. This thing agrees completely with the range space which we had earlier. For me to determine this probability distribution now, I am now going to draw a diagram like this. I'm now going to draw something like this. Draw something like this, which is what I had earlier. I have here x, I have here p of what? Of x. Then as usual, I have this. Here is my 0, 1, 2, and 3. Then I will now return back here. I am talking about 0 head here. In how many places did it occur? 1 place. So 1 over 8. So I have 1 all over 8. I am at 1. Here is a 1. In how many places did it occur? 3. I have 3 over 8. I am at 2, which is this 2, is 3. So I have 3 all over what? 8. I am at 3, which is 1. I have 1 over what? 8, which is exactly what we had there before. Okay? So this is the approach that we should be using when the number of coins increases or the number of trials increases, and we are asked to determine the range space and then to determine what we call the probability distribution. With this table now, we can begin to sum a lot of probability questions where they might be asking us, what is the probability of obtaining 2 heads and a tail? What is the probability of obtaining 2 heads or 4 heads? All of these things are different probability questions that can be raised. So thank you very much and stay connected as we are now going to go over immediately to the probability distribution of the toss of 4 fake coins using this approach that we already established here. Thank you very much and stay connected.